Today we're going to be talking about polynomial long division. And yes, long division implies the existence of short division, in case you're wondering. Polynomial long division works exactly the same as like the long division you learn when you're in elementary school. When we're going to do this, we're going to put, I'm going to say it's standard form. Standard. That means what we're doing is we're going in order of decreasing exponents. If they're not in order of decreasing exponents, it ain't going to work so good. I would say I've tried, but I haven't because I generally follow directions. If you end up with some place that is a blank, you're missing a variable, you need to put a 0 to hold the place of the sign, okay? And that is just to keep yourself organized. The hardest part of this is maintaining your self-organization. It's not, the math of this is really pretty stinking easy, but it's really easy to accidentally get disorganized, and if you're off by one little space, it all gets jacked up, and then you say bad words because you got to do it again. Don't ask me how I know. So since it is done like long division, it also is set up exactly like long division. So your divisor and your dividend go in the same places. And for these, we're going to be old school. We're going to use the old oblius, which is the bent spoon looking thing. So what I'm going to do is I'm going to start by writing the big monstrosity. So I'm going to put, let's see, 2x to the 4th plus x cubed. That's 4, 3 minus 2x squared, 2 plus 9x. 1, I'm going to double check. 4, 3, 2, 1. Cool. Plus 5. And we're going to do the bent spoon kind of thingy. Oh, man, I cannot draw a straight line to save my life on this. That's really rough. Holy cow. And then 2x plus 1, our divisor. All right. So when we're doing this, I'm going to start by giving a little bit of logic. The thing that is the first one here, we're going smaller degrees, okay? So this is going to be a blank. I'm just going to put that there to remind us we don't put anything over our first number, okay? If you try to, it's not the end of the world, but it won't make so much sense as you go trying to do working. So just, let me see, let me update these attendances here. Saw Angel come in and Javier come in. All right. So my goal, okay, this is kind of the weird part. Can I add some more colors so I can make this look prettier? Let's add a new pen. I would like to add, let's say, orange, because why not? I want to make my coefficient and my exponents match. So goal number 1, okay, I want my 2x squared. I don't care about the plus 1 so much at the moment. Look at my 2x squared, and I want it to match 2x to the 4th power. So to do that, what I'm going to do is multiply 2x by x cubed, right? Easy enough. So above the x cubed, I'm going to put x cubed. And that's not got to do with this, it's got to do with this. So x cubed times 2x is going to be 2x to the 4th. And then x cubed times 1 is going to be plus x cubed. I've really got to work on drawing my lines. And this is going to work legit just like division. So these two cancel out. I get a 0. These two cancel out. This is a little unusual. I also get a 0. And just in case you forgot, from it's been a bajillion years, we then pull down the next number, and I get a minus 2x squared. So my goal here is honestly pretty easy. So what I'm going to do for ease is erase this one, because it's always going to be 0. And let's change colors to, and do black. Okay. I want my 2x to match a 0. So I'm going to multiply by 0. Do I technically need to put that there? The answer to that question is no, not really, but I'm doing it, again, for the sake of organization. I don't want to confuse myself. So 0 times all that stuff is going to be 0, right? Just 0, like this. 2x squared, negative 2x squared minus 0 is going to be negative 2x squared. My next term falls down. We get a plus 9x. Add more pen colors. We're going to have all kinds. No, I don't want a pencil. Ah, man. I want a pen. Pens are nicer. Let's do green. Do enjoy a good green pen. All right. So again, what I'm going to do is I'm going to say 2x times what is going to give me a negative 2x squared. And that's going to be a negative x. So negative x times 2x will give me negative 2x squared. Negative x times 1 will just be a negative x. Okay? Negative 2x squared minus negative 2x squared gives me a fat 0 right here. Good. And then 9x minus negative x will be 10x. And then we're going to pull our 5 down. When you're doing these, make sure you're keeping track of your integer rules. Stuff like that, it's really easy to say, oh, that's going to be 8x. And then the rest of the problem gets messed up by accident. I've done it. I still do it occasionally, but just kind of keep it in the back of your head. Let's see, now what do we got? Oh, do I got any more colors left that I can use? Let's do this pretty blue. Okay, so I've got, I want to make 2x equal to 10x. So I'm going to multiply it by 5. 5 times 2 is going to be 10x's. 5 times 1 is going to be 5. That's really convenient. 10x plus 5 minus 10x plus 5 is 0, so I have no remainder. So when I'm done, my final answer is x cubed minus x plus 5. So you can see this, like, it's repetitive and it takes up a mountain of space, but mathematically it's not super challenging. The only thing that I would like to add is that remainders work the same way that they did when you were in 4th grade. So let's say that my remainder was 10x plus 5, right? It's not, but let's pretend. If it was, we're going to take our answer like normal, and at the end, we would just put our remainder, so let's pretend it was 10x plus 5, over what you divided by. That's all you have to do. If you've got a remainder, then you're done. These are, it seems like, why would you ever use this? Honestly, this is a lot of work. Why would I do it? This is a good way to do factoring in certain circumstances. There's going to be a trick that we use with synthetic division that also lets us evaluate functions extremely quickly to help us factor. If it's not a quadratic, maybe it's a 3rd degree, and we're trying to figure out what the zeros of it are, that help you get that done a lot faster. So I think you can see the organization is what keeps you going here. Let's do another one. Maybe this one will be shorter. If we're with any luck, this one will be shorter. Okay, so we're going to do 2x cubed minus 14x squared plus 72. Now, there's a slight problem here before I draw my line. 3, 2 when we skip one. So I'm going to put a plus 0 here. Oh, 0x, not x squared. 0x plus 72. And that is entirely just to keep me aligned. And then x minus 6. All right, let's start with blue. I want x to match 2x cubed. So I'm going to multiply by 2 and an x squared. Remember, we don't put anything over the first number. So 2x squared times x will be 2x cubed. 2x squared times negative 6 will be negative 12x squared. These guys cancel. Perfect. Negative 14x squared minus negative 12x squared will be negative 2x squared. Don't let that fool you. And then we're going to pull down a plus 0. It seems stupid, I know. Placeholder. Go my next color. Now I want x to match negative 2x squared. I'm going to say minus 2x. 2x times x will be negative 2x squared. Negative 2x times 6. Negative 2x times negative 6 will be positive 12x. Now you kind of see why I kept that 0 there, just to make sure things aligned right. Those guys are canceled. 0 minus 12x will give us negative 12x, and we'll pull down our 72. I want x to match negative 12x, so minus 12. We get negative 12x. Negative 12 times negative 6, that's really convenient. And then negative 12, it should be a positive 72. And then those two cancel each other out. We get 0, no remainder. So our solution would be 2x squared minus 2x minus 12. Which means if we multiplied 2x squared minus 2x minus 12 times x minus 6, we'd get that big old polynomial again. Whew. Right. So let's do one that is, I'm going to say this level of difficulty, less hard than the first one was, but I'm going to show you what to do when you end up with a remainder, just in case you get kind of a weird answer. I know some of you guys, when you get to a weird answer, you go, Mr. Clark, did I do it right? You probably did. I have faith in you. Weird answers are okay. All right, this one starts off as a classic fraction, so we're just going to rewrite him real quick. But we got to do it in order, because if you look at it, the numbers are all out of order here as far as being in descending order. So let's go ahead and get that sorted out. So we got an x cubed minus an x squared plus 4x and then plus 6. And then this is x plus 2. All right. Next color, gonna go with blue. I want my x to match an x cubed, so I'm going to do an x squared. This becomes an x cubed. X squared times 2 will be 2x squared. We'll subtract. Those guys are gone. Negative x squared minus 2x will be negative 3x squared. Again, the integer rules. You got to watch out for them. And then we'll pull down this plus 4x. Next color. I'm going to sneeze. Hold on a second. Doing it. They always come in pairs. Except this one, apparently. All right. I want my x to match negative 3x squared. So we're going to multiply it by negative 3x. Negative 3x times x will be negative 3x squared. To cancel, negative 3x times 2 will be negative 6x. We'll subtract. These guys are gone. 4 minus negative 6 will give us a 10, so 10x. And then pull down our 6. Go green. I want my x to match 10x, so I'm going to multiply by 10. Give me 10x. 10 times 2 will be 20, so plus 20. The 10s cancel. And then 6 minus 20 is what, negative 14? All right, Mr. Clark, what do I do with this 14? That's the remainder. X squared minus 3x plus 10 minus 14 over x plus 2. And that's how you do the remainders. Easy peasy. I will say that when you're doing this with an application, like you're trying to solve something or something like that, you're probably not going to end up with these remainders too frequently, or if you do, you're not going to use them. So don't worry about it being weird or how am I going to graph that or any of that kind of stuff. I promise it will not be a large issue. All right, I think we have one more example. Well, this is a gross one. Okay. Rewrite this in the correct order. We got a 3, a 2, and a 1. So negative 4x cubed minus 8x squared. Be a minus, not a dash. Minus plus 32x, and then plus a 0 for our constant. Whee! Let's see, and our divisor is x squared plus 2x minus 8. My handwriting got really bad all of a sudden right there. All right, so this one's going to be a little bit weirder. I want x squared to become negative 4x cubed. So that's negative 4x, right? Negative 4x. Negative 4, and we get negative 4. Okay, negative 4x times 2x will be, negative 8x. This is convenient. Negative 4x times 8 will be, so we get a 32x. Holy cow. That cancels, that cancels, that cancels. We get a 0, and then we pull down a 0, and we're done. Sweet. The answer equals negative 4x. Sometimes they work out nicely, even though they're kind of hideous. All right, so the gist of today, this is not mathematically difficult, it is organizationally difficult. If you have atrocious handwriting, I did when I was in high school, so no judgment, graph paper can help. The other thing that might help if you don't have graph paper, if you take your notebook paper or your journal or whatever, and you turn it sideways so you have columns instead of rows, that can also help you if that's a problem that you have. If not, I wouldn't worry about it. This works exactly the same as the division you learned how to do when you were little. So I don't think there's anything that should be too new here. I'm only going to do one day of this, and then I'm going to teach you synthetic division, which you will like a lot after seeing this. Basically, what we're going to do on Thursday is all of this work right here we can do in about a box, I mean, an eighth of the size. So 2 lines instead of 12. It's pretty sweet. The assignment, I believe, is on Delta Math. If anything's mucked up about it, please let me know. If you have any questions, I am totally here for you.